Alrighty, so today we are going to look at set notation. So this is 9C, and that's using symbols and different types of notation. So if we look at the Venn diagram here on the right, we're going to look at the English explanation, the mathematical meaning, and the number in the Venn diagram. Okay, so the first one, if we talk about not having A, so A is everything in this circle here. So if we want not A, it's going to be everything on the outside and everything in B. So it'll be 3 and 4, which would be 7. Okay, if we're talking about not A, the mathematical term for that is the complement of A. If we look at the next one, A or B, so it can be either A or B, so it could be the 9, the 1, or the 3, so 13. The mathematical way of saying this is A union B. Okay, part C, A and B. So in circle A and in circle B is just that middle bit there. So it's just going to be the number 1. A intersection B, so that's where the circles overlap. And then the last one, anyone, could be this, 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 or this. And we refer to that as the sample space. So all elements are considered. There are 17 elements. So that's when we write our curly E and 17. So looking at the key ideas for this section, the sample space, and that's all of our possible outcomes. So if we're looking at this example here, we've got the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. It's sometimes called the universal set, and it's given the symbol an S, so S for sample space. Here we've got omega, U for the universal set, or we also have this curly E, which is called xi. Set A is a particular subset, so it's like a C that's a little bit elongated to the left of the sample space, if all of the elements in A are contained in the sample set. So for example, if this here, the 2, the 3, the 5, and the 7, they are all contained within our sample set, our sample space, using the same example throughout all these dot points. So 2, 3, 5, and 7 are all a subset of our sample space. A dash is the complement of A, and it contains the elements not in A. So it's, if you're looking at the Venn diagram that we had before, it's so we want the circle of A, but the opposite, and that's what this diagram here gives you. Okay, so when we have the dash, it's the opposite. 5, this elongated E, means that 5 is an element of, so 5 is an element of A, and 0 with a dash through it is the null set or an empty set, and it contains no elements. N is the cardinal number of A, so it means that the number of elements in A, so the number of elements in A, up here we've got 2, 3, 5, and 7, so there are 4 elements in A. A Venn diagram can be used to illustrate how the different subsets in the sample space are grouped. So if A contains the numbers 2, 3, 5, and 7, B contains the numbers 1, 3, 5, 7, and 9. So which numbers are in both A and B? So we've got 3, 5, and 7. So there are 3 of those. So that's that number there. The numbers that are just in A is just the number 2. There's only one of those. The numbers that are in B is 1 and 9. So there's 2 of those. And remember we had numbers 1 to 10 in total. So the numbers that we haven't spoken about yet are 4, 6, 8, 8, and 10. So there are 4 of those, and that's that number there. So we usually write the cardinal numbers inside a Venn diagram. So our total numbers, so there were 10 total numbers. The total that were in A and B, so those are the ones we circled pink. The total number that were in the whole circle of A is 4, so that whole circle. The total number that were just in A is 1. The total number that were not B and not A, so that's the 4 that we had in blue. And the total number that are in B but not in A are 2. So we usually write the cardinal numbers inside the Venn diagram as we've done above, and then we've got our two-way table as well. So A, N, B means A and B, so and intersection. A, U, B, so it means A or B, or the union of A and B. So that A or B, if we're looking at a Venn diagram, it could be anything in that circle or anything in that circle. Okay, if we're looking at a Venn diagram for A and B, it's just that overlap bit, just that bit in there. So this one is A and B, or NB, and this one is A or B. So I like to think of that as a cup, that you can put everything into that cup. Only is the elements in A only is the elements in A, but not in B. So the elements in A, but not in B is just the number 2. So there is only one of those. Looking at these examples on the next page, they match each of the terms in the first list with the symbols in the second list. So the complement. So we've got A dash, I'm just going to write them here. The union, so U for union, and that just means or. A dash means not A. The element of. The intersection, that means and. Empty or null set is our naught with a cross through it, and the number of elements, that's an n. Question 2, choose a diagram that matches each of these sets. So let's just go through and label these 4. So we've got 2 circles and it's just the middle bit shaded. So this is A and B. Part B, we've got all of A and all of B shaded. So that could be A or B. C, we've just got B shaded. So that's B only. And part D, we're looking at not A. Okay, so we were to shade A and then the opposite, and that gives us everything that was previously shaded there. So this one is A dash. Question 3. Using the given two-way table, state the following. The number, so n, remember, stands for the number, in A and B. So A and B is the number 2. Part B, the number in B, so the total in B is 10. Part C, the number in A is 7. And part D, the number that is not A is 9. Okay, looking at example 5, using set notation. The number is chosen from the set of positive integers between 1 and 8 inclusive. A is the set of odd numbers between 1 and 8 inclusive, and B is the set of prime numbers between 1 and 8 inclusive. List these sets, so the sample space. So that's all of our numbers between 1 and 8. What are the numbers in A? So it's all of our odd numbers. So 1, 3, 5, 7, and not 9 because 9 is not in the set. 1, 3, 5, and 7. And B, what are in B is just our prime numbers. We've got 2, 3, 5, and 7. Part B, draw a Venn diagram. Okay, so we've got a Venn diagram here. We're going to label that as our third step. So we're going to do part C first. List these sets, A and B. So what falls in A and B? So we've got the number 3 falls in A and B. The number 5 and the number 7. So 3 is in both of them, 5 is in both of them, and 7 is in both of them. Part 2, list the numbers that are in A or B. So we've got 1, 2, 3, 5, and 7. 1, 2, 3, 5, and 7. Don't forget my curly brackets. What numbers are not in A? So if you think of all of the ones that are in A, we want the opposite of that. So not 1, so we want 2. Not 3, but we want 4. Not 5, but we want 6. Not 7, so 8. B only. So what numbers are in B and nothing else? So that's just the number 2. Okay, so now let's put what we know into our Venn diagram. We're only going to just put the numbers, okay? Not individually write each out. So A and B, there are 3, 1, 2, 3. So we'll put a number 3 in here. Then we looked at A or B. We had 1, 2, 3, 4, 5 numbers. So that means the total in like this number plus this number plus this number is going to be 5. Part 4, B only. So there's only one number there. So that means this has to be a 1. And then we're also going to look at the numbers that are not included in A or B. So the numbers that weren't included at A or B could be written as A or B not. Okay, so the complement. So what numbers aren't here? Well, that's 4, 6, and 8. Okay, and then, so there's 3 of those. So 3 there. The total number is 8. So 1 plus 3 is 4, plus 1 is 5, plus 3 is 8. So it all adds up. Part D, find the number of elements in A. So that's that whole circle. So it's 4. Find the probability of A. Okay, so it's the number of elements that are in A divided by the total number of elements. So it'll be 4 over 8, which equals 1 over 2. Find the number that's in A and B. So that's 3. And find the probability. So that's always written as a fraction. N is just always written as a number. A and B is our middle number, which is our 3. So 3 over Great, and we can't simplify that. There we go. So have a go at exercise 9C, and then please submit your work on the portal. Have fun.